Yo, what's up? Still me. I have to wear this jacket, but look at this polo. It doesn't. This couldn't be any more epic. What I mean is, what's up, everyone? Still the great teacher, Alcantara. It feels so weird saying that, but yeah, it's still me for the meantime. And welcome to another video. And you might be wondering, why am I wearing this thing? Why am I recording here again? It's gonna make sense. This one is gonna be a bit different. It's gonna be more about storytelling and the lesson in particular. So I hope you guys would enjoy it. So let's just jump right into the lesson. In this journey with the Little Prince, we will be talking about something that I am honestly, to be honest with you guys, really excited to talk about because it's something that is near and dear to my heart. Before we go there, let's just hop right into it. If you know what I mean. I mean, I said it earlier, but who cares? Now, before we proceed, I want you guys to solve this one thing carefully. I would like you to take your time. For example, here we have 25 minus 55 plus the quantity 85 plus 65. And the answer here, if you wouldn't believe it, the answer is actually 5. But the 5 here is not just the number 5, there's something right after it. And this one right here is what we call as the factorial notation. This 5 here, 5 factorial, implies that the answer will be 5 times 4 times 3 times 2 times 1, and that is 120. And if you solve this one right here, it's going to be equal to 120 also. So that's a concept that I want you guys to get from this short thing that you're seeing on the screen. Okay, a bit straightforward, right? But that's the point anyway. It's a bit straightforward in the video format. Now, in this case, I want us first to understand this lesson, and with the help of something that I would like to call as the anagram of us. Basically, what we're going to do here is you will be shown 5 different words, and your goal is to find the anagram of each word based on the description given. So basically, an anagram is where you have to flip all of the same letters that are given from the previous word, and you have to form another word using the same letters. No repetitions, no removal or whatever. We're gonna use the same old letters, and you can pause some parts of the video if you wish to answer it on your own. So first off, let's have the word savior. What would be the anagram of savior if the word that we're looking for means different from each other? That would be various. And next, how about if we have the word file, and we're looking for something that means the period from birth to death? This would be life, right? It's so easy, right? And next, how about gates? The one that we're looking for means a particular point or period. This should be stage. That's correct. And next, how about if it's pets? And the one we're looking for means an action or proceeding. This one should be step. That's correct. How about this one? Rats. And the one that we're looking for implies visible in the sky, especially in the night. That's none other than a star. And here, with all these words that we've used, all of these anagrams, actually, we have to think about this. Like, what can we observe between the words and their anagrams? What was done with the letters in each word to find their respective anagram? So in here, I would like to imply that we have these 2 different words with the same letters used. They have different meanings, but they have the use of the same letters. In order for us to get that, what we did was we rearranged them. So the arrangement is the one thing that I want you guys to take note of from the previous activity. And you might be thinking, why those words in particular? Well, I actually wrote a short poem which I would like to call as the anagram of us. So the anagram of us, I wrote a tanka. It's a kind of a Japanese poetry that follows the syllabic pattern 57577, wherein I wrote various worlds in here, different colors of life, walking the same stage, unique paths in every step, on their way to their own star. So this is a tanga that I wrote roughly 5 years ago, I think. And the purpose of this is for you to understand that this journey that we're going to take in this lesson is something that you can ponder with your life in terms of how you're dealing with your life, how you're moving with it, how you take this stage of your life, what kind of star you're chasing. So we're gonna discover it all together with the help of our friends from the Little Prince. So let's now hop on from one cloud to another. And in this case, our first activity after the previous one would be what's my password? So in the story of the Little Prince, but there's a rose there, okay? But I would like to say this is a differentiated version of the Little Prince, wherein in the far too distant future, the Rose of the Little Prince put a number lock on its glass case to protect herself. Because in the short story, we knew there that the Little Prince wants to take care of this rose, and he's watering the rose. He protected it with a glass case. Now, what the rose did is put a password on it to make sure that she will be safe. But the problem is that she forgot the right order of its four-digit passcode. What could be the possible codes if the only thing she remembers is that she used the numbers 1, 2, 3, and 4? So let's put it in a glass case. And I want you to think about this. This is where the application of permutation comes in, which is our lesson. I spoiled it up a little bit, but the problem is this. How will we be able to answer this question? And are we talking about the specific pattern, the specific password? Well, technically, no, because the question is what could be the possible codes. The word possible implies that we can try multiple amount of codes in here. And in this case, these are the things that I want you guys to think about. Is it important in getting the correct password given the four numbers to take note of the arrangement, the numbers used, the repetition, and at the same time, is the code 1234 the same as 2341? And how many possible codes are there that we can try out in order to open this glass case? So basically in this, there are three different methods that you can use. And I'll just show two of it because the other one is basically relying on the first one, which is basically the listing method. So if you have the time in the world, you can simply list down all of the possible passwords ranging from 1234, 1243, 1324, 1342, 1423, 1432, 2134, 2143, 2314, 2341, 2413, 2431, 3124, 3142, 321, 43241, 341, 2421, 4123, 4132, 421, 3423, 143, 124, and I lost my breath doing that. That was a bit dumb, but that's by listing method. There are like 24 numbers in there. 24 passcodes that you can try out. And in this case, you can actually make it simple. You can put it in a tree diagram where you start with the number 1, followed by the possible second digits, and so on and so forth. You can try that out. But the easiest way, based on the question itself, to answer it is what we call as the fundamental counting principle, where we will apply the notation, factorial notation, that we showed earlier in the beginning of this video. So 4 factorial is equal to 4 times 3 times 2 times 1. And now you might be wondering, why is it 4 factorial? Basically, it is based off of the given that there is a 4-digit passcode. And there are 4 possible numbers. Which of them is correct? Which one of them is true? That's what this is what we're gonna find out. Okay? So in this case, permutation is of n objects in an ordered arrangement, and it can be determined by listing, tree diagramming, and by the FCP of the fundamental counting principle. So if you're going to apply the FCP based on our first given, it is NPN, where n factorial is the permutation of n taken n at a time, where n is the number of objects. The objects that we were talking about in the previous example are the numbers. So we have 4 objects there, 4, 3, 2, 1, and again, we're looking for 4-digit passcode too, so it fits. It's 4 by 4. Now, again, the concept of factorial is that if you have, for example, 4 factorial, your goal is to start from 4 and you'll multiply to all the numbers until you reach 1. 4, 3, 2, 1. Now, if you might be wondering, if you want to research about it, it's a trivia. If you have 0 factorial, the answer there is 1. And it's a long process. I don't want to try to explain it, but if you want to, you can research about it. It's a long one, I'm not kidding. But anyway, going back, so now let's have some examples based on it. So in how many ways can you arrange the letters humble? HUMBLE. So you have 6 different letters here. And again, since we want to rearrange them, the 6 letters themselves, so it's going to be 6 factorial. So by FCP, we're going to have 6P6. So it's going to be
6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1, or 720. As easy as that. And next, what if we have this? The three different worlds that are in Little Prince. So we have the king there, the lamplighter, which is me probably. That's what my student said. I guess it's the businessman. My eye is a bit disoriented right now. I'm so sorry, but the case is this: in how many ways can you arrange the worlds below? Like, for example, you're the little prince or you're the protagonist. Like, in what order do you wish to meet these people? If you have the chance to reorder it, so well, basically, you can have as easy as 3 factorial because there are 3 different worlds involved. So if it's 3 factorial, it's going to be as easy as 3 times 2 times 1, and it's equal to 6. That's how easy permutation is, specifically if it's the concept of n taken n at a time. So in this case, as we continue, what if we have an example like this? For activity number 3, we call it as the best of all worlds. Now, other than Earth, there are actually 6 worlds that the Little Prince visited, and we're going to talk about it. So first off, by the time the Little Prince's journey got to Earth, again, Earth is not counted because that's the place that he landed on, he tries to rank the top 3 worlds he visited. In how many ways can he rank a first, second, and third place among 6 worlds he visited prior to Earth? So now it's like those times when someone journeys in life, right? That you try to somewhat think about all those best moments or best places you've gone to, like the end of a trip, probably. You have like, oh, that's a favorite, that's a favorite, that's a favorite. Now you try to rank them. So basically, that's the point of this part. So this is what I want you to think about first. Since it will be ranked from third to first, or first to third, on whatever order it may be, how will that affect the number of ways the rank can be given? Is the answer supposed to be 6 factorial, just like earlier? Why or why not? So that's what we want to talk about here. Now, what I want you to understand is earlier, we're basically rearranging the 6 letters or the 6 numbers or the 3 worlds. But now, what we need to do is to rank them up, like the possible rankings. How many ways can we have it? Like, there's a competition, there's a voting system. How does this work? Well, basically now, there will be a limitation. So for this limitation, we're going to have something like this. It's no longer n taken n at a time. It will now be the formula involved for permutation wherein it's npr, or n taken r at a time, where n is the number of objects and r represents the number of objects to be arranged. So here, the number of objects in the worlds is 6, right? As for the number of objects to be arranged, we have there 3 because there's 3 places: third, second, first, or first, second, third. So in this case, if we apply it to our word problem earlier, in how many ways can he rank a first, second, and third place among 6 worlds he visited prior to Earth? Well, it's as simple as 6p3, wherein it's 6 factorial for sorry, now I'm stuttering. 6 factorial all over the quantity 6 minus 3 factorial. So the formula is basically as simple as n factorial all over the quantity n minus r factorial. The quantity there is really important because if you don't do that, you're gonna get the wrong answer. So it will be 6 taken 3 at a time, where the answer will be as simple as this. Now, the reason why I want to show the long solution first, so that you will understand that there are different techniques where you can solve problems like this. Sometimes if you don't want to use the formula, you could actually find a pattern. As you can see here, we showed also the evaluated version of each factorial notation. For 6 factorial, we have 6 times 5 times 4 times 3 times 2 times 1. For 6 minus 3, that will be 3. So it will be 3 factorial. So it's 3 times 2 times 1. So here, if you multiply all of them, you're going to get 720 over 6, or 120. So that's the long version. If you want to cut to the chase, you can have something as simple as this. As you can notice, the first part is the same, but it changed in the second part. Instead of having 6 until 1, we now have 6 until 3 factorial. Basically, this technique implies that you stop your numerator to the number that is the same as the denominator. Again, you stop the numerator with the same number that is in the denominator. The purpose of this is as simple as cancellation because it's multiplication. So we can cancel it out. We can divide it out. So if you divide 3 factorial by 3 factorial, the answer there is 1. So you can cancel that out. So you have 6 times 5 times 4, which is 120, which is actually one of the actual techniques on how to solve that kind of problem. So not only are those two solutions on your screen possible, there's another one. Basically, if you think about this, you need three places, right? So you have three spaces for it, wherein you have six possible winners for the first place. Since if you ever you choose one there already, you will have five people remaining for the second place and four for the third. So it's six times five times four. That could be another way to interpret that. It's your choice which one you would like to use, because basically permutations, you can have multiple possible solutions. So to put this into perspective, let's have another example. Assume that in the Little Prince's world, there are still 10 worlds that the Little Prince is yet to see. In how many ways can he rank 10 worlds from first to fourth? So now, instead of having the things that we have in the story, let's imagine, because, in this life, not only is it just six worlds before, we get old and stuff like that, we're gonna go to different places. Pa. So this, like the Little Prince, let's say that in this vast universe, in the Little Prince, there's still 10 yet to be discovered. So, in what way can he rank these 10 worlds from first to fourth in terms of like the first place he will go to until the fourth? So in here, it's as simple as applying the formula NPR, and here we're gonna have 10P4 because there are 10 worlds and again, four rankings. In this case, it's as simple as here. And again, you can try the different techniques I mentioned earlier. In this case, I stop at 6 factorial so that I can cancel that out. Why is it 6 factorial? N minus R is 10 minus 4, so that will be 6. Then you stop at 6, you cancel that. 10 times 9 times 8 times 7, that's equal to 5040. As simple as that. So basically here, what I'm trying to say is that it doesn't have to be complicated, it is manageable. And here, assume that there are 12 rulers in the Little Princess Galaxy. An election is held to choose a president, vice president, secretary, treasurer, and auditor. In how many ways can the officers be chosen? Again, this is something that is true in real life. This is something that we see from time to time. Like, especially in classes, right? Before the start of this, before we begin actual work as students, we are asked to vote for who would like to be the president of the class and so on and so forth, the class officers. And in this case, in the universe, what if we have this too? And it's as simple as 12p5. And why is it 12p5? Because there are 12 rulers and there are president, vice president, secretary, treasurer, and auditor. 5 different places. Not necessarily places, 5 different positions. I'm so sorry. So 5 different positions for election. So it's 12p5, and we stop here by 7 factorial in the solution because 12 minus 5 is 7. As simple as that. So we'll have 12 times 11 times 10 times 9 times 8. That's 95,040. And that's how many ways we can have different kinds of combinations of people there, arrangement of people there. The combination is actually not yet here. That's not our lesson yet. It's going to be the next one after this. But as for this one, what I would like you to understand is life in permutations. And this question, I want you to actually think about it for a little bit. Like in your personal experience, to what can you relate our lesson permutations to? I stopped for a second there, so I think you could pause it right there if you know what I'm saying. But basically, me, the reason why I'm discussing this, I will mention it in the yapping part of this video. There will be one. So, yeah, it's going to be a long one there. It's your choice if you want to watch that. But basically, for me, I just want you guys to realize that the reason why I'm still posting this video, even though it's a little late, is because the arrangement of things in your life, it's gonna be different for others too. So you should not be scared or somewhat pressured to be in the same pace as them. But if you can find a way to be near it, if there's a way, there's a will. You just have to do it. Just don't dwell on something that you have a solution for. Okay? If you can't do it, then it's not your it's not on you. That's life. But if you can do it, then go for it. Again, just take your time, think a lot, think of everything you got. That's from Father and Son, one of my favorite songs. You want to check it out too. And basically here, it's said in the book The Little Prince, nevertheless, he is the only one of them all who does not seem ridiculous. Perhaps that is because he is thinking of something beside himself. This is a quotation from the part wherein the Little Prince saw the lamplighter, and the story there is this. I might repeat it in the last part. I don't remember what I said in the video. I'm so sorry, but One of my students, Axel, told me that he drew me for one of his English outputs, and I was the lamplighter. He compared me to the lamplighter. From what I remember, that's what he told me. And at first, I was like, "Why me?" And it doesn't make sense to me because I read The Little Prince before, and I didn't appreciate it much. And I said to myself that I'll read it again once I'm ready. And after like a few weeks, I decided to read The Little Prince in one go. And when I reached that part, I realized that indeed I'm a lamplighter, and man, that was really like cathartic for me. Like to be seen by someone as the lamplighter, I really feel like I was seen and I was appreciated, even though they don't know how to say it straightforward. Because I think the purpose of this is that I'm in a point in my life now. Like if you see the arrangement of the things that happen in my life, it's filled with ups and downs. But this journey in particular is something that I'm truly grateful for. It's the part where uh, I get to do something every day. It's tiring. I even say out loud how tired I am sometimes, but I will do it in a heartbeat because it's something that I'm cursed to do, you know? But it's a lovely curse to be in, to be an educator, to be a lamplighter, to be a torchbearer. That's what we were called in Philippine Normal University. We are torchbearers, and to be compared to a lamplighter, that's that's as poetic as something can get. So basically, that's it for permutations for now. And I'm stopping this video here because I just want to spotlight this story that I have. And yeah, one more lesson spotlights, lessons, two more lesson spotlights in the future. But for now, it's about permutations.
And that ends the lesson for permutation, taken N and taken R at a time. So I decided to put them together in one video lesson because it fits the concept that I'm working on here. I think I mentioned in the previous videos lessons that I want to try something different, and this is one of them because one of the things that I like doing before when I had a lot of time in my hands is that making these lessons in a story manner, like not just math. I wanted to have a theme, and I decided to go with the Little Prince this time, and I just thought it would be really good to share it with you guys. And I know that this part you guys don't reach this much. That's why I like yapping here. So I just want to say this. I was thinking of putting this as an outtake so that people will look at it, but I doubt. I don't really like getting views sometimes. I don't know. It's a weird thing about me. But um, what I can say is that I just somewhat decided last night that I'm gonna work on this slides, this story, this lesson, as if it is my way to somewhat make a complete circle. Permutation was the lesson that I discussed when I applied as a teacher, and I think I'll show it here probably. This the side by side comparison of my slides 5 years ago when I applied here and the slides that I did. Of course, you saw it already from the lesson, but the funny thing about that is how 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 far I've come since then, and with the skills that I've learned and how to work on them. And you know, today was a bit of a struggle because I was scared, especially since I put this much effort in this work, and I know that it's not always gonna hit. It's not always gonna hit. Students have gotten accustomed for me to be somewhat a bit relaxed, and when I'm strict, they know that we cannot really break zero counter. It's just gonna be like that. And I've come to that part that I shouldn't just worry much. If they want to be a part of it, they want to be a part of it. I'll just let them be. And you know, that was my fear today that I put this much effort in this one that it might not work. And I realized that in some classes it did, in some classes it didn't hit at all, in some classes it somewhat got a direction. And isn't that the point of it at all? Like you have to try and try until one succeeds. And one of the reasons why I decided to combine the concept that I worked on 5 years ago with the Little Prince was that one of my students compared me to the lamplighter in the Little Prince, where if you read the book, the lamplighter is someone who just simply lights up the lamp every single time. He hates it and a little bit he dreads it, but he keeps doing it over and over. And I told my last class that earlier. I told them how much I had been dreading seeing them sometimes because of how crazy they are, of how repetitive it was. But every single day, I'll still choose to be there. It's kind of like the love that I've gotten um, used to, with the kids. But now it feels weird because I once saw myself as a lamplighter. Until now, I guess, I still am. That's why we call ourselves as the torch bearers of PNU, here to light up the students, teach them, to reach them, hence the poetry earlier. So this was my star 5 years ago, to be an educator. And the reason why I'm wearing this, because this is the same thing that I wore 5 years ago when I got the news that I'll be graduating the same day that I applied for CSA. And now I think it's a complete circle. And it feels weird that I'm gonna have more sessions after this. This felt like a goodbye to me. But then if you realize in the Little Prince, they have these kinds of realizations before the end. So in a few weeks, the Little Prince suddenly just disappeared with no traces at all, as if it wasn't there. And you know, I was thinking of disappearing too. Like, don't worry, I'm not gonna kill myself. Um, I just want to disappear far from all of this because I've dedicated like my entire life for this one, for teaching. It all circled to this. I've been working for 5 years, yes, but it all led to this moment, and I think I'm ready to go to another planet in some case. We'll see. We'll see. So it's gonna be an enjoyable ride because we don't know what tomorrow holds. And as for you guys who are listening to this, the reason why I wrote poetry 5 years ago is because just like permutations, the sequence of things, of our priorities in life are different. And as for me, this is the one that I led with, that I got to teaching. And now I think I have to somewhat go back. In some, it's going to be linear, like to their goal, but for me, I have to go back somewhere. It's not going back to square one, but I will begin again, and we'll see where it will lead me. So thank you for listening to me, Yap. I would like to laugh at it, but I'm a bit serious for this one. I don't know why. It's a bit dramatic, I know, and you didn't come for this one, but maybe it will reach you somehow. So maybe if you're at the part of your life where you're like, I want to reach that. Why are they there and why am I here? You'll compare yourself to people sometimes. But hopefully you realize that you don't have to, because at the end of it all, we are walking at our own pace, and we all have our own stars. My star, this looks like a dot to you, but it means the world to me. So who knows? As much as possible, enjoy the ride. It's gonna be one hell of a ride. And you're not thinking of what heaven feels like. Because the only way you'll know that is when you're not here anymore. That's why no matter how hellacious this ride is, you have to live for it. You have to live through whatever happens. And instead of just thinking about one day I'll be this, one day I'll be that, why not make it a day one? It's just what it is. So this is gonna be like the second or maybe third to the last. I don't know, man. In case you don't see me, good morning, good afternoon, good evening, and good night.